In this screencast, I'm going to begin talking about working with the Preos spreadsheet and the PVT tab specifically. This workbook is distributed with the worksheets protected. However, values that are shown in blue font can be changed without unprotecting the sheet, and this is helpful to understand. Alright, let's go to the PVT tab. And on the PVT tab, the worksheet is divided kind of into 4 different regions. In the top table here, I enter the compound of interest. In this case, methane is pre-entered. In the center table, I have the temperature and pressure of interest, and then I have columns that represent the compressibility factors, the volume, and the fugacities that have been found, and the rows represent the 3-root region or the 1-root region. In the table over on the right, I have the intermediate calculations of the equation of state parameters, the equation of state A and B, and the dimensionless A and B that we've discussed in other lessons. I also have a cell here for fugacity ratio, which helps me know when the system is stable. And if you look at this, at the conditions that are in the spreadsheet, the fugacity ratio is 1. Both of these fugacities in the 3-root region are equal to each other, which means they're equally stable, and the system is at phase equilibria. So these happen to be saturation conditions for methane. In the lower region, I've got the calculations that determine the solution to the cubic. The method is described in Appendix B of the textbook if you're interested in the details. Also below are some directions about how to use solver tools to find saturation pressure and saturation temperature, and I'll cover that in a separate video. Alright, so at conditions we've already determined that this fluid is at equilibrium, so if we raise the pressure a little bit, the liquid should become more stable, and you can see that that has happened. This is the volume. 33 is going to be a liquid-like volume, and now that root is more stable because it's got a lower fugacity. If we go a little bit lower than 0.1, we should get the vapor being stable, and you can see that that indeed has happened. Okay, let me show you how to change fluids. If I go to the Quit Props tab, I can pull out some properties for other fluids. Let's change it to ethane. We only need to collect through the eccentric factor row. I'm going to right-click and choose Copy. And I'll go back and I'm going to right-click and choose Paste Special to paste values. In that way, the cells don't get protected. Alright. Now I can just go ahead and happily change away the temperature and pressure and calculate properties for ethane. In a subsequent screencast, I will show how to use a solver tool to find vapor pressures.